In the last two videos, we introduced the idea of arrays. We saw that an array is a list of elements, all of the same type, accessed based on their position or index. If we combine that idea with using loops, we will really start to see how useful arrays can be. Let's do that now. Here's our final program about the daily high temperatures from the first video in this series. The only change I've made is to initialize all four elements right away in the declaration. This statement is particularly unwieldy. Imagine how awful it would be if we were calculating the average for an entire month or year. Notice that we are doing exactly the same thing with each and every element of our array. This kind of repetition is a good place for a loop. First, we will separate out this declaration from the assignment. And to make things a tiny bit clearer, let's move this division by 4 to happen in its own statement as well. Now we can see clearly that our loop needs to access each element in our array and add the value of that element to a total. In the end, our variable average temp will be used to hold the average, but at this point, we can use it to hold the running total. So before we add in any array elements, the variable starts at 0. And for each element in our array, we will add that element into average temp. I've used I here as the index variable. So what value does I need to loop through so that I'll get every element in my array? We can see from our old statement that I started at 0, the first element of the array, and finished at 3, the last element. So we will start I at 0, go until we get 3 as our last value, and access each array element in turn. Can you see a different way to write this comparison? It is actually more common to see it written this way, and you'll soon see why. We need to do one more thing here to make our loop work properly. Do you see what it is? We need to declare our variable I. In some versions of C, you can do this inside the loop header itself, where we initialized I to 0. But in others, that isn't allowed, so I'll put it here. Let's add a couple of printf statements to the program so that you can see it looping over the array elements. And compile and run our program. On the 4 iterations of the loop, I went from 0 to 3. And on each iteration, accessed the appropriate element of the array. Now let's think about what would need to change in our program if we had temperatures for an entire year, 365 measurements. Our array would need 365 elements, and we would need to initialize them somehow. That would still be a bit ugly for now, but by the end of the course, you'll know how to read these values in from a file. Our average would be over 365 values, so this would change. And now our loop would start at 0 and go up to, but not including 365. In all 3 of these locations, we are using the size of the array. In fact, this is a good place to use a pound-defined constant, so that if we change our program to work on a different number of days, we won't miss one of the places that needs to change. Now I'll bet you can see why it is more conventional to write the loop condition using less than rather than less than or equal to. We have seen how to combine arrays and loops to write short yet powerful code to perform tasks on large quantities of data. We will see many more examples of using arrays and loops together in later videos.